Hello, everyone. Welcome back to this live series on data science with Python. And till now, in this live series, we've learned all about Python. So we've learned about the basics of Python. We did some problem solving. Going ahead, we learned how to deal with object-oriented programming when it comes to Python. After that, we also learned how to do data manipulation with this library called as pandas. And then we also did some data visualization with the library Seaborn and Matplotlib. And then, following which, we learned about the fundamentals of statistics and implemented some basic statistics with Python. And then today's session, we will start our machine learning journey. And in today's session, we'll be covering this algorithm called as linear regression. And since this is a live session, you can go ahead and put in your questions in the chat, and I shall be taking them up. So let me just check from my side if the audio and video is proper. Okay, seems like I can see myself on the screen and the audio is also good. Now, on that note, we'll go ahead and dive into this session. So, this is all about linear regression, and linear regression is an ML algorithm. Now, for those of you who do not have an idea of what machine learning is, consider this where humans are learning. So how do we learn? Well, it is a repetitive process. We are told about something and then we learn about it. So let's say if you as a kid were shown an image of a dog and told that this is a dog, so you were shown maybe five or six of these pictures and were told, hey, this is a dog. Similarly, now when you were given a new picture of a dog, or when you actually went out and saw a dog in real life, you knew that this object or whatever this structure that you saw, this resembles a dog, and you knew immediately that this is a dog. And this is how machine learning works, right? So you feed it an input data, and for that input data, you'll have some sort of labels. Now, you do this again and again so that whenever you give it new data, it'll automatically recognize that this belongs to the label of whatever you give it. So if you feed it an image of a dog, it will recognize that this is a dog. So that is how supervised learning works. And under supervised learning, we have something called as linear regression. So in today's session, we'll understand linear regression through this case study. So let's say you have different sets of cars with you, and you would want to understand the relationship between the mileage of a car and the horsepower of a car. Okay. So what you do is you collect all of the information and you make a tabulated structure. So you take up your Excel sheet. So in one column, you note down the horsepower of different cars, and in another column, you note down the miles per gallon, or basically the mileage of all of these cars. Now, once you do it, well, you can't really get much information from this, right? So this is basically Excel data or tabular data where you have two columns and you're listing down the values of these two columns. But if I wanted to find out more information from this, what I can do is I can create a scatter plot or I can create a graph. So here, what I'm basically doing is I will map this horsepower onto the X column and I'll map this mileage or miles per gallon onto the Y axis. So what I'll do is 130 will be over here on the x-axis and 18 will be over here on the y-axis, and I'll have a point denoting that, right? So similarly, this point over here, this basically denotes that particular car where the mileage would be somewhere around 195 or something, and then its mileage would be closer to around 10. Similarly, if we take this particular car, so this would be a car whose horsepower would be around 75 and its mileage would be around 15. And if you look at this entire graph at one go, you'll understand that this is an inverse relationship between miles per gallon and horsepower. That is, as the horsepower of this car increases, the mileage of this car decreases. And this is what I mean by an inverse relationship. And this is also an inverse linear relationship. That is, as and when you increase the horsepower, the MPG or mileage decreases. So you can actually draw a straight line, a hypothetical straight line through this, and that will tell you that if the horsepower increases, the miles per gallon will decrease linearly. So this is what we can understand through this graph. But What if I were to change the question? So till now, from this graph, we were only able to understand that there's a relationship and it's an inverse relationship. As the horsepower increases, the mileage decreases. But if I were to pose a question, if I were to ask if, the horsepower is something, what would be the mileage? So let's say if the horsepower is 130, I would want to know what the mileage is. So can I directly guess it from the graph? Well, it wouldn't be so easy. And this is where linear regression comes in. So, in linear regression, now simply put, what this linear regression helps us with is it helps us to find the relationship between two or more variables. So, here you can consider your x to be the independent variable and y to be the dependent variable. That is, you'd want to understand how does y change with respect to x, or with respect to this data set you'd want to understand how would the mileage of the car vary with respect to the horsepower of the car. Now, here in linear regression, since it is based on a linear line, right? So I'll just draw a straight line through this. Now, when I draw a straight line through this, this will have an equation because every line has an equation, and this will tell me or give me an idea of the mileage when I have certain value of horsepower, right? So if I basically take this particular line and if I draw a vertical line like this, so if I drop down a vertical line onto the x-axis, so the horsepower would be somewhere around, let's say 162. And also if I drop a horizontal line like this onto the y-axis, then the mileage will be around 12. So this over here, this linear regression line will give me a value of MPG when I have a certain value of horsepower, right? So if the value is around 160, then if I draw a line like this, then I'll get the mileage to be around 12 or 13. So this is how linear regression works. But there could be a scenario where instead of this line, I might have this line, right? And in this case, if maybe the horsepower were over 160, so here, if I take the value to be 160 over here, and if I drop a horizontal line like this, then the mileage comes to be around 17. So with this, the mileage comes to be around 13, but with this line, the mileage comes to be around 17. Similarly, there could be another line. So this time, if I were to take this horsepower. So horsepower is around 160 and the MPG or the mileage would come to be around 20. So there could be infinite such lines which could go through this data. So how do you know which is the best fit out of all of these? So this is where you will find out the residuals of these. So let's say here, or we'll take this particular data point over here. So here the horsepower is 75 and the actual MPG or mileage should be 15, right? So for this particular car, horsepower is 75 and the actual output or Y value should be 15. But these three lines, they predict something else. So for this value of 70, this particular line tells you that the MPG is around 25. This tells you MPG is around 30. This tells you the MPG is around 35. So this is the residual or error in prediction. So you can just subtract this. So the actual is 15. The predicted is around 25. So 25 minus 15 will give you 10. So that is the residual in prediction. Here this would be 30 minus 15. Here this would be 35 minus 15. Now what you do is there'll be residuals for each such point in the graph. So you take up the squares of all of these residuals and you sum them up. So this is called as residual sum square. And whichever line will have the lowest residual sum square, that would be your best fit line. So, in other words, whichever line has the lowest error across all of the points in this graph, that is your best fit line, and that is what linear regression helps us to do. So now that we have understood the basic idea of linear regression, we shall go ahead and implement this in Python. Let me go to Google Colab over here, and what I can do is, so this is the MPG dataset, and this is part of the Seaborn library. So I would need to import the library. I shall type in import cborn as SNS, and I would also need the sklearn library. I can actually import that later on. I would also need matplotlib, so I'll type from matplotlib import pyplot as plt. So these are the two libraries that I have imported. Now, this MPG dataset or miles per gallon dataset is part of the Seaborn library. So I shall go ahead and load that. I will type in sns.load dataset. Inside this, I shall give in the name of the library, which would be MPG. And this is what I get. I shall store this in a new object and I shall call that to be cars. So these are the different columns which are there. So here are the names of all the cars. So you have Chevrolet, you have Buick, you have Plymouth, AMC, Ford, Pickup, Dodge, and so on. And you have the miles per gallon, displacement, horsepower, weight, acceleration, model year, and so on. Now I'd want to understand the relationship between miles per gallon and the horsepower column. So the first thing which we did was go ahead and we made a scatter plot between these two. So if I want to make a scatter plot, what I can do is I can type in sns dot scatter plot and I would have to map something onto the x-axis. So horsepower will go onto the x-axis. X is equal to horsepower and I would want to map something onto the y-axis. So MPG will go onto the y-axis and these two columns are part of the cars dataset that I have created over here. So I will set the data to be equal to cars and I will type in plt.show and let's see what will be the result. Cars is not defined, so I'd have to run the cell over here. Let me run this again. And this is the same graph that we had in the presentation. So as you see, there is an inverse relationship between MPG and the horsepower column. So as the horsepower of this car increases, the miles per gallon would decrease. So that is what we understand from this. But what I want to do is, if I were to given a horsepower value, I'd want to predict the miles per gallon value, and this is where linear regression comes in. So for this, I would have to use the sklearn library. So sklearn library is used to implement all of your ML algorithms. And before we actually go ahead and implement the linear regression algorithm, I'd have to divide my data set into training and testing sets. Now, that is important because you don't build your entire model on top of the entire data set. You build your model on top of the training data and you predict your values on top of the testing data. Now, this is important because you don't want to overfit your data on top of your entire population. So, this is something which you will further learn in more of statistics and probability classes. So, on that note, I will go ahead and import something called as a train test split. And this is part of sklearn library from sklearn dot model selection. I shall be importing train test split. This is the method that I shall use. This will take in two values. So this will take in x and y. So I would need the x value and the y value. So I would need to extract those. So x would be horsepower and y would be MPG. Since this is part of the cars class, I would need the horsepower column and I'm storing it into X. Similarly, from the cars data set, I would need the MPG column. I'm storing it into Y. Let me print out the head of this. I'll have X dot head and also Y dot head. And you shall see that I have the first five records of these two columns. Okay. I have extracted the X and Y columns. Now I shall go ahead and pass these two inside this method, which is train test split. And there is another parameter which is called the test size. So I'll set the test size to be equal to 0.3, which would basically mean that I have 30% of the data in the testing set and the rest of the 70% of the data in the training set. Now you'll need more data for training and less data for testing. So this is something which you can keep in mind. And this will give me four values. I'll store them in X train. Then I'll have X test. After that, I'll have Y train. And then I'll have something called as Y test. So X train is the training data for your independent variable or X variable. So basically training data for your this would be X was horsepower, and then you have testing data for horsepower. Similarly, you have training data for mileage and then testing data for mileage. Okay, we have all of this. Now that this is done, I can go ahead and import the linear regression model. So for this, from sklearn dot, there would be a submodule called as linear model. So from sklearn dot linear model, I would want to import linear regression, and that is what I shall import. And I shall create an instance of this. So I'll say LR is equal to linear regression. So I'm just creating an instance of this. Now, with this instance, I can train this on top of the training data. So basically, I'll fit this model on top of X train and Y train. I'll type LR dot fit X train, and then the next parameter would be Y train. Okay, so now one thing that you have to keep in mind is this model that you're trying to build, this will not work if there are any values or missing values or null values present in the data. So that is why before this actually happens, before I actually get the X and Y values from the data set, I'll go ahead and drop the null values. So I'll say cars dot drop NA, and I'll store it back in cars. Now, let me run this entire thing again. Let me run the fit method over here, and this should work properly. And we see that we have successfully built this model on top of the training set. Now it's time to predict the values on top of the test set. So I'll have lr dot predict, and I'll be predicting this on top of the test set. So here I pass in only the test set of the X, or the basically the horsepower, because I would want the prediction for MPG, right? So this is the test data for horsepower, and on the basis of test data for horsepower, I would want to get the prediction results for this MPG, and I'll store the results in a new variable, and I'll call that to be ypred. I'll hit enter. Now, I want to have a look at the actual values and the predicted results. So the actual values were present in Y test. I'll have a glance at the first five records. Similarly, I'll have a glance at the first five records of this. So YPRED, this would be a list. So I shall be using list indexing. So the actual values over here were 16, 26, 35, 23, and 32, and the predicted values were these. You see that there is a residual in prediction, right? So the actual value was 16, the predicted was 11. Actual was 26, predicted 29. Actual 35, predicted is 27. So this is the error in prediction. Now I would want to find out the residual sum of squares, which would mean that I will subtract the difference over here. I'll get the error. Similarly, I'll get the error. And then I'll square all of these errors and I'll sum them up. So that is what is called as residual sum of squares. Now for this, there is something called as residual sum square in the sklearn library. Again, I will type from sklearn dot, there would be a submodule called metrics. From sklearn dot metrics import, this would be residual sum square. Or let's see what are the options over here. Max error. So this would be mean squared error. So we have mean squared error. So that is what we shall be using. So mean squared error is another name for residual sum of squares. So you're basically taking the squares of this and then taking the means of the error. And now In mean squared error, I shall go ahead and pass in the actual values and the predicted values. So the predicted values are present in white, red, and this is the mean squared error that we get. So you can consider this to be one of the lines that we fit through the graph. So you can go ahead and build several such linear regression models, and whichever model will give you the lowest value of mean squared error, that would be your best fit line, or that would be your best fit linear regression model. Now, I haven't yet shown you the prediction. So what I did was over here lr.predict, and I passed in the entire data set. Now, instead of this, maybe if I were to give in some value of horsepower, and if I wanted to predict the miles per gallon value for it, let's see how can we do it. So here, I'll copy this, I'll paste it over here, I'll remove this. So we know that there is an inverse relationship between horsepower and miles per gallon. So horsepower, let's actually see the range of horsepower. So it ranges from 50 to 225. So I'll give the horsepower to be around 200. So I need to give this as a 2D array, and I shall give in the value of 200. And here, so you see that if the horsepower is 200, your mileage would be 7. Let me reduce this. Let me make it 100, and you get a value of 24. Let me make it back to 200. So 200, the horsepower is high. If the horsepower is high, the mileage will be low, which is 7. If I change this, if I make this to be 100, we shall see that it has shot up. It has become 24, and that is what we see from here. If the horsepower is high, your MPG will be low, and if the horsepower is low, your MPG will be high. And that is exactly what this linear regression model predicts as well. So, friends, in this particular lesson, we have learned the theory and the implementation of linear regression. And in the future sessions, we'll be covering more such machine learning algorithms. So if you've liked this one, do hit the like button and also subscribe to our channel and share it with your friends and family members. Thank you very much, and I'll meet you in the